the frictional force is always equal to mu into n, defining some angle alpha. And alpha is called angle of repose. Then what is this friction? How do I understand friction? To understand friction, please note that friction is a self-adjusting force. It has to be rough in nature. So I have considered Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing my discussion on laws of motion, in today's class, we will discuss a beautiful concept called friction and the different kinds of friction. And also, we try to understand what is meant by angle of friction. So the first thing that I discuss in today's class is the meaning of friction. Please do note that friction is one of the common forces in nature. We have studied the different types of common forces. So friction is again a type of common force. On a chill day, when the weather is very, very cold, we rub our palms together so that heat is generated. And we say here, heat is generated due to friction. Then what is this friction? How do I understand friction? To understand friction, let us follow the given example. Follow the example now. I will consider a rough horizontal surface. Some rough horizontal surface, like the surface of a table, surface of a plane. It has to be rough in nature. So I have considered a rough horizontal surface. And I place an object, for example, book, on the rough horizontal surface. There is a rough horizontal surface, and I have placed a book on the rough horizontal surface. Now there will be a downward force acting, which is due to the weight of the book. We studied downward force due to gravity. Under the influence of gravity, what we call as weight. And opposite to this weight, The force acting is called normal reaction. It will have the same magnitude as the weight, but acts in opposite direction to the weight. Action, reaction. Weight acts downwards. Reaction acts upwards. Now, I will apply a horizontal force, a force parallel to the horizontal surface. And immediately I believe, because the horizontal force is applied, the book starts moving. No. On contrary, as soon as the horizontal force is applied, the book doesn't move. Slightly increase the horizontal force, still the book is stationary. Why? The reason is, in the opposite direction, there is a force acting called the frictional force, which will oppose the motion of the book. Or I can say the frictional force opposes the applied force. Only above a certain limit, called frictional limit, when this frictional force breaks down, the book starts to move. Therefore, by nature, friction is a self-adjusting force. Please note that friction is a self-adjusting force. Why do I call self-adjusting? As the applied force increases, frictional force in the opposite direction also increases. Increase the applied force, friction also increases. Only after a certain limit, friction breaks down. It is self-adjusting. It adjusts itself to the applied horizontal force. So friction comes into picture only when the two surfaces are in contact. The surface of the book should be in contact with the horizontal surface. Only then friction comes into picture. Now, analyzing the different kinds of friction, basically we say there are 4 kinds of friction. Static friction, kinetic friction, rolling friction, and limiting friction. The 4 kinds of friction that can be seen is static friction, kinetic friction, rolling friction, and limiting friction. By the understanding of friction, we told it is coming into existence only when the two surfaces are in contact. By nature, it opposes the applied horizontal force, or we say it is adjusting itself to the horizontal force and thereby called as self-adjusting force. Hence, then, what is static friction? The moment I say static, it means at rest. I consider two surfaces placed on each other. They oppose the relative motion between them, but they don't move or respect with each other. They are static. They don't move with respect to each other. They are relatively at rest. In such a case, friction developed is called as static friction. Here, the two surfaces are in contact. They are static. They don't move with respect to each other. They oppose the relative motion, and that is what we call as static friction. The second one is called kinetic friction. The moment I say kinetic friction, it means the two surfaces move, or the two surfaces slide with respect to each other. Kinetic friction agate. The two surfaces are in contact. Again, they oppose the relative motion of each other, but they slide or move with respect to each other. Such type of friction coming into picture is kinetic friction. Static friction, when the two surfaces in contact are at rest. Kinetic friction, when the two surfaces in contact slide or move with respect to each other. Rolling friction, exactly coming into picture. The tire of cars, tire of carts, etc. When a body rolls over another body, especially you can say this type of friction comes into picture where there are spherical surfaces where rolling happens, and this type of friction is better because the point of contact is less. And finally, limiting friction. When two surfaces are in contact and they don't move with respect to each other, what type of friction comes into picture? Static friction. The maximum static friction a body can exert on the surface of another body is called limiting friction. It is the maximum static friction. Maximum static friction a body can exert on another body. And this limiting friction is directly proportional to the normal reaction between the two surfaces. Eliminating the proportionality, we write Fs max is mu into n, where mu is a very, very important term called coefficient of friction. So the four types of frictions are static friction, where the two surfaces in contact are at rest. Kinetic friction, where the two surfaces in contact move or slide over each other. Rolling friction, where the surface spherical bodies roll with respect to each other. Limiting friction, where the maximum static friction body exerts on another surface. And please know, the frictional force is always equal to mu into n, where mu is called coefficient of friction. Now, we study something called angle of friction. What is this angle of friction? It is defined as some angle, as the name itself says, angle of friction. Angle between the normal reaction and the resultant of normal reaction and limiting friction is called angle of friction. See, means to say, if you observe here, this is the body which is placed on a rough horizontal surface. And this is the frictional force which acts opposite to the applied force. And this is the normal. What is theta? Angle between the resultant of the normal reaction and static friction is called angle of friction. Again, I say it is some angle between the normal and angle between the frictional force. Their resultant angle is called angle of friction. So now, from the triangle ONM, or I say OSM, tan theta is OS by MS. So tan theta is MS divided by OS. MS is nothing but OA. OS is nothing but N. F by N. But F by N is mu. So tan theta is always equal to mu. Please know this relation. Coefficient of friction is always equal to tangent of the angle of friction. Mu is always equal to tan theta, or we also say theta is tan inverse mu. So this is angle of friction. Very important relation. Tan theta is equal to mu, or theta is tan inverse mu. Now we study something called angle of repose. Here, horizontal plane and inclined plane. The body starts moving down on this inclined plane, defining some angle alpha. And alpha is called angle of repose. It is the angle between the horizontal plane and the inclined plane. Keep in mind, repose, angle between horizontal plane and inclined plane, where the object just begins to slide down. So dear students, we have studied a very important topic called friction, types of friction, angle of friction, and angle of repose. Next, we study the applications, disadvantages of friction. Until then, have a nice time. Thank you.